right, so on this one, basically what we're doing, keep it as simple as possible, guys. Don't get like crazy and putting a whole bunch of these together. It's asking us on task 2, it says, make an alkane with an alkyl functional group. All right, so the easiest thing to do is to take 3 carbons and link them together. So would you do that for me right now? Just take 3 and put them in. Okay, so then what we end up having is basically propane, right? Now, I'm going to ask you guys to go ahead and put the white balls on there because you're going to need to do that to be able to count them. I'm not going to do that just for like speed purposes here, okay? But remember, we have this like this, and then our drawing would look like this to start with, right? So we're half done with the first part of task 2. What's the second thing it asks for? It says an alkane with a alkyl. So how about just keep it simple and let's just add a methyl. So all we'd have to do is that. Then what I'd like for you to do is go ahead and put all of the hydrogens around here. So then when you do that, you could just count them up and you'd know that that would be C4H10 if you end up counting, because there's 3 here, 3 here, 3 here, and 1 here. 3, 6, 9, 10 is what I'd get. Do you guys see how I got that? There'll be 3 up top here. Oops, can't see one. There's 3 here. There's 3 here. There's 3 here. And then there's only 1 bonding spot left on the back here. So that's how you get the 10. Okay. So the longest chain on this thing is called propane, right? And since off of the second carbon, we've got a methyl. And remember, the methyl is just an alkane that's hanging on a bigger alkane. It's a baby alkane. Okay. It's a smaller alkane that's hanging on a larger alkane. So the name of it would be 2-methylpropane. Click, take a picture of it. Okay. Questions on that guy? We good with that?
Can you run this fast? We're going the same place.
Oh, okay.
Sorry.
Glad you ladies got that. That's good. All right. So can I move on to the second one? Okay. So let's look at the second one here. And it says make an alkene with an alkyl. What does that mean, an alkene? Double bond. So really, to be honest with you, you can just keep this and just pull. So don't pull off the hydrogens yet. Okay. Pull off this like this as I throw one down. No, I launched it. Okay, so what I've got to do is I've got to take the springs, and remember, by themselves, the springs don't represent anything but just single bonds. But when you have 2 springs put together, like that, and like that, and you attach them to another one, now that creates a double bond. Because some people were having trouble with that. They just thought if they took a spring and stuck it in there that represents a double bond. It doesn't. Okay, so now that by itself looks like this, right? Then I need to complete this because it's an alkene with a methyl is what I'm going to make. So it looks like that. Can you guys see the double bond? Hopefully. Okay. So now what I've got is pro, and then how do I end it? since it's a double bond. Ene. And it's on the first carbon, right? That one is telling me that it's on, this ene is on the first carbon. And then on the second carbon, there's a methyl. So it's 2-methyl-1-propene. And I just need to put my hydrogens on there. Make sense? Okay. So let's tackle the third one. You guys good? So now just figure out a way to get a triple bond. All right, well, we're gonna have to move some stuff around here. It's not gonna be quite as easy as what we just had, but I think we can get it done. So form the triple bond and take a look at it and now go, okay, now I got a little bit of a problem, because if I just think that I can add that and say, yep, there's my methyl group, that's not a methyl group. Can anybody tell me why this is not a methyl group? Where is it not located? In the middle. Methyls always have to be in the middle. Right now it's on the end. That doesn't work. What I have here is fine. We're going to keep this. We're not going to tear it up. We're going to keep this. Is going to be how we're going to get our alkyne with an alkyl. Okay. Right now we've got 1, 2, 3, 4. 4 is what? 4 carbons makes what? Bute. And then if it's 3, I end it with what? It's not ane, it's not ene. Ine. And we're saying it's off the first one. Now we're half done. So then take and put on a methyl. But you can't put it there. Don't put it on this one because it's not in the middle. Put it here. Okay. So if this is number 1 carbon, that makes this number 2 carbon, that makes this number 3 carbon. So on the third carbon, there's a methyl. So it's 3-methyl-1-butene. So if we draw this out, 1, 2, 3, 4, make your triple bond like that. And then it doesn't matter if I go up or down, I'm just going to go up. So that would be my drawing. Now, here's the complicated part. You really need to probably put all the carbons or the hydrogens on here to figure this out. If you don't, it's fine. There's a math thing you can do, but it's 1, 2, 3, 4, 5, H, and then I know that there's going to be 1 over here, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there's the first 3, like I just did for you. Good? Take a picture of it. Okay. So then the next one that we'll go to is a cycloalkane. Cyclo just means it's in a circle or it's in a geometric shape. Okay. So all we need to do, after I took a picture of this, I'll break it apart, but I'm going to use these springs. And I'm going to make the simplest cyclohydrocarbon that I can. Because like I said, just keep it simple. And it asks for a cycloalkane with an alkyl group. Okay. Well, here's my cycloalkane. Do you see that? It's just 3 carbons that are bound together in a geometric shape. All right. So I end up having a carbon, a carbon, a carbon, and a carbon like that. So I have these 3 carbons bound together. Well, normally we don't write the C's, right? So we just draw a triangle like that. So there's that's half. We're halfway done. And then what's the second part? We need an alkyl. Okay, fine. Here's methyl. Just put it on one of the empty spots. So It's hanging off right here. So it's just a line. Okay? And then we need to go ahead and put our hydrogens on all these. All right? So we end up having C4H. There's 2 here, 2 here, and 1 here. There's 2, 4, 5, 6, 7, 8. If my math is right. 3, 4, 5, 6, 7, 8. I get 8. And then our name for this is going to be cyclopropane. And then we always put the functional group in front. So, and we're going to say it's 1-methyl. Okay? All right, so that just leaves us one thing, I believe, right? And it's a haloalkane, right? All right. So if it's a haloalkane, let's just make this as simple as possible. And let's just use these two. I'm going to make it 3 because it's easier to draw. And we're going to call this orange one. Let's just make it a chlorine. Okay, so the drawing would look like this. Right? And then put your hydrogen. Now you'll notice that this chlorine, there's no other bonding spots, right? There's no other holes because chlorine only has one bonding spot. So this is going to be 3 hydrogens here. Okay, it's going to have an extra hydrogen here. I need to think about doing it this way. This works, doesn't it? Hey, looky there. Stubbs got smart for once. All right, so then that gives us 3 carbons, right? And 3, 4, 7 hydrogens and 1 chlorine. So there's our chemical formula. And then we can call this propane. And since it's on the second one, we're going to call it 2-chloropropane. Now, you guys feel like free if you want to make this longer. Don't use chlorine if you got something against chlorine. If you're anti-chlorine, you go for it. If you want to make it bromo or iodo, okay, or fluoro, that's fine. All right. Okay, so that is task 2. Okay, you got the video if you want to go back and watch it. That's great. And then task 3, I'm going to leave it up to you guys. And it's asking you, this is where your creativity will come in. You're going to construct with 12 carbons, all right, a hydrocarbon that has 12 carbons and at least 1 double bond or 1 triple bond. Okay, make it as complex as you want, as long as you have 12 carbons. It doesn't mean there has to be 12 carbons in a row. You could use like methyl groups and ethyl groups and things like that. You could turn them into cyclos, which some people did. Like, for example, the 1-heptanyl cyclopentane. I had somebody 4th hour do that thing. Yes, I had to look it up to figure out how to name the pentanyl part, or heptanyl part. Questions? Okay. Let me stop this.